What if I told you that 15 billion miles from Earth, a dying spacecraft just sent back a measurement that should not be possible? Not a malfunction, not an error in the data. A real reading from the only kind of machine that has ever left our solar system, and it broke the rules we thought we understood about the space between the stars. The spacecraft is Voyager 1, and it launched 48 years ago, before most of the people watching this were born. It was never built to do what it is doing now. And out there, alone in the dark beyond everything we know, it found something that scientists still cannot fully explain. Everything we believed about the edge of the solar system said one thing should happen as a spacecraft traveled deeper into that emptiness. Voyager crossed that edge, and the exact opposite happened instead. Before we get to what it found, you need to understand where it is and how impossibly far it has gone. Because nothing humanity has ever made has been this far away, this alone, or this close to the end. Let me take you out to where Voyager 1 actually is right now. It launched on September 5th, 1977, from Cape Canaveral on top of a rocket, carrying a machine that weighed about 1,800 pounds and was roughly the size of a small car. By the standards of the phone in your hand, its computers are almost laughably primitive. The entire spacecraft has less memory than it takes to store a single modern photograph. And yet that machine has traveled farther than anything else our species has ever built. Today, Voyager 1 is more than 15 billion miles from Earth, drifting in the direction of the constellation Ophiuchus. It is so far away that its radio signal, moving at the speed of light, takes almost an entire day to reach us. When you send it a command, you wait nearly a full day for the message to arrive, and then nearly another full day for the answer to come back. Stop and think about that for a moment. Every conversation we have with this spacecraft takes 2 days, across a gap so vast that light itself struggles to cross it. For the first part of its life, Voyager 1 was a tourist of the giant planets. It flew past Jupiter and discovered a thin ring around the planet and 2 new moons no one had ever seen. It swept past Saturn, found 5 more moons and a faint new ring, and then it was deliberately flung up and out of the flat plane where all the planets orbit, sacrificing any future visits in exchange for a chance at something no one had ever done. It pointed itself toward the edge of the solar system, and it kept going. And for decades after that, it traveled through a region the sun still ruled, a vast invisible bubble blown by our own star. But that bubble has a wall, and in 2012, Voyager 1 reached it. To understand what happened next, you have to understand the bubble we live inside. The sun does not just give off light. It blows a constant wind of charged particles outward in every direction, a stream called the solar wind. And that wind inflates an enormous bubble around the entire solar system. Every planet, every moon, everything you have ever known sits inside it. Scientists call it the heliosphere, and for a long time we assumed this bubble simply faded away at its edges. The old idea was that the solar wind would gradually weaken the farther it traveled, thinning out gently until it quietly blended into the space between the stars. That was the model, and that was what everyone expected Voyager to find. On August the 25th, 2012, Voyager 1 became the first object ever built by human hands to cross that boundary and leave the bubble entirely. We call the edge the heliopause, the line where the sun's wind finally loses its grip and interstellar space begins. And the moment Voyager crossed it, the old model fell apart. Because the solar wind did not gently fade, it hit a wall. Voyager recorded a sudden, sharp boundary, where the warm, thin gas of our solar system gave way almost all at once to the cold, dense gas between the stars. The probe measured a steep jump in the density of the space around it, the signature that told scientists it had truly crossed over. There was no slow fade, there was a shoreline. And once Voyager was on the other side of that shoreline, in the true dark between the stars, it began sending back numbers that no one could fully explain. Here is what everyone expected once Voyager was out in interstellar space. The gas out there is denser than the gas inside our bubble. That part, scientists had predicted so far, so good. But then the strangeness began, because as Voyager traveled deeper into interstellar space, the density did not hold steady. It did not thin out, it climbed. Think about how strange that is. You are moving away from everything, deeper into what should be the emptiest place imaginable, the void between the stars. And the farther you go, the more crowded the space around you becomes. The numbers are tiny, but the pattern is unmistakable. Just outside our bubble, Voyager measured a density of around 0.04 of a particle in each cubic centimeter of space. But as it pushed deeper, that number rose, climbing toward roughly 0.12 of a particle per cubic centimeter, 3 times higher the farther out it went. Something out there is squeezing the space between the stars, something is compressing it. And to this day, scientists cannot fully agree on what. One idea is that the magnetic field of interstellar space drapes over the outside of our bubble like fabric pulled tight over a curve and squeezes the gas as it presses in. And here is the part that supports that idea and deepens the mystery at the same time. When Voyager crossed the boundary, it measured the magnetic field out there to be stronger than anyone had predicted. The space between the stars was pushing back on our solar system harder than our models ever said it should. So this is the impossible thing Voyager sent home. Not a sound from aliens, not a secret message, but something stranger, because it is real. A region of space that behaves backwards from everything we expected, growing denser as you leave. Pressed in by forces we still do not understand, measured by a machine built in the 1970s from 15 billion miles away. And then, in the middle of all that strangeness, Voyager heard something. For years, the only way Voyager could measure the gas around it was to wait for our own sun to shout. Every so often, the sun would hurl out a violent burst, and that burst would travel all the way out to interstellar space and slam into the gas around Voyager, making it ring like a struck bell. The probe would catch that ringing and use it to measure the density. But between those bursts, there was only silence. And then, examining the data sent back from more than 14 billion miles away, a young Cornell astronomer named Stella Koch-Ocker found something underneath the silence, a sound that never stopped. In 2021, she and her team announced that Voyager 1 had detected a faint, steady, monotone hum coming from the gas of interstellar space itself. Not a burst from the sun, not an event. A constant droning signature, the sound of the space between the stars, humming on its own. It is incredibly faint, and it sits in a tiny, narrow band, which is why it took so long to find. One of the senior scientists described it perfectly. He said the interstellar medium is like a quiet, gentle rain. When the sun sends out a burst, it is like a sudden crack of lightning in a thunderstorm, and then afterward, it goes back to that soft, endless rain. That hum is not noise to be ignored. It is the very thing that let Voyager keep measuring the climbing density of the dark, continuously on its own, without waiting for the sun to shout. A dying machine, listening to the faint rain of the galaxy, and quietly telling us how strange that rain truly is. But while Voyager was listening to the dark was beginning to win. So here is where this story turns, and I want you to hold one thought in your mind. This machine is almost 50 years old. It is the most distant object we have ever built, and it is running out of time. On November the 14th, 2023, Voyager 1 stopped making sense. Engineers could tell the spacecraft was still alive. They could see it was still receiving their commands, still pointing its antenna at Earth, still trying. But the data it sent back had turned to gibberish. A meaningless repeating pattern of ones and zeros, pouring across 15 billion miles, signifying nothing. Imagine that for a moment, the most distant voice humanity has, the only machine that can describe the space between the stars, suddenly reduced to a single, endless, broken note. The line was still open, but Voyager's voice was gone. The team traced the problem across that impossible distance and found the cause. A single chip inside one of the spacecraft's 3 onboard computers had failed. About 3% of its memory was corrupted, and that small piece happened to hold code the whole system needed to speak. They could not replace the chip, and they could not send a technician. The nearest human hands were 15 billion miles away, so they did something extraordinary. They decided to take the lost code, break it into pieces, and tuck those pieces into other empty corners of the spacecraft's aging memory, rewriting how a 1970s computer worked while it drifted in interstellar space. And every single attempt was a step into the unknown, because each command took nearly a full day to arrive, and each answer took nearly a full day to return. They would send their fix, and then they would wait almost 2 days to find out if it had worked or if they had just lost the spacecraft forever. The project manager later admitted how frightening it was. She said it was the most serious problem they had faced and that it was terrifying because you lose communication with the spacecraft and you do not know if you will ever get it back. They sent the first piece of the fix on April the 18th, 2024, and then they waited 2 days of silence across 15 billion miles. And on April the 20th, after 5 months of nothing but a broken note, Voyager 1 answered. The data came through, clear and coherent, for the first time since the previous autumn. The most distant machine we have ever built had come back from the dead. But every rescue out here only buys a little more time, because Voyager is dying, slowly, in a way no fix can stop. Its power comes from the heat of decaying plutonium, and every single year, that source gives a little less, losing about 4 watts of power annually. The lights are going out, one by one. To keep the spacecraft alive as long as possible, engineers have spent years switching things off, heaters, instruments. In 2024 and 2025, they powered down still more of its science experiments. And in April of 2026, they shut down another instrument that had been running almost without pause since 1977 for nearly 49 years. Each shutdown is a small, deliberate amputation, trading away a piece of the spacecraft to keep its heart beating a little longer. NASA hopes that, if the spacecraft holds together, at least one instrument might keep sending data into the early 2030s. But the engineers are honest about it. The question is no longer whether Voyager will go silent, the question is only when. And when that day comes, the spacecraft will not stop moving. It will simply stop speaking. It will keep drifting outward at tens of thousands of miles an hour, carrying the questions it raised but could not answer, deeper into the dark it spent its life describing. It also carries something else, a message. Bolted to its side is a golden record, a gold-plated copper disc assembled by a team led by Carl Sagan, holding greetings in 55 languages, the sounds of our world, and a map of pulsars showing where, in all the galaxy, this machine came from. It was meant for anyone or anything that might one day find it. And after Voyager goes silent, that golden record will keep traveling, long after the spacecraft has gone quiet, long after the people who built it are gone, long after our sun itself has changed. A message in a bottle, thrown into an ocean so vast it may never wash ashore. So think back to where we started. A dying machine, 15 billion miles away, sending home a reading that should not be possible. We have spent this whole time treating that as a puzzle to be solved, an anomaly to explain, a mystery we will eventually understand. But here is the truth that stays with me. The space between the stars was growing denser and pressing in and humming its faint, endless rain long before Voyager ever arrived to measure it. It was doing all of it in total darkness, with no one watching, for billions of years. And it will keep doing it long after Voyager falls silent, indifferent to whether we ever understood it at all. We sent one fragile machine to the edge of that darkness, and it sent back just enough to tell us how little we actually know. Then its voice will fade and the dark will close over the questions, and the readings that broke our models will simply go on being true, 15 billion miles away with no one left to record them. So here is what I keep wondering. When Voyager finally goes silent, when the last signal fades and we are left with the questions it never answered, will we ever build something brave enough to go out there and finish what it started? Tell me what you think, and thanks for watching.